My name is Elisa, I'm from Italy, and I'm from Milan.
My name is Lihen, I'm from Israel, from Netanya.
From?
Netanya.
Netanya.
I don't know what's happening with the projector.
There you go.
Okay, so hello everyone again. We're presenting a new approach for underfloor. A new approach for underfloor heating with the usage of phase change materials. Oh, where's that clicker? Sorry. So, why do we need to improve the consumption in buildings? Well, a building consumes about 40% of the world's energy. As well, they're responsible for 50% of the CO2 emissions that go into the air. Big problem. Now, the heat consumption in buildings around the world is mainly used, as we can see in the diagram, for space heating. More than 50%, as we can see here. Now, we have different ways of changing and making sure our room stays in thermal comfort. We have air conditioners, we have radiators, we have fans. But we're going to focus on one main, most efficient one today. Infrared underfloor heating. So what is this technology we're talking about? But basically, infrared, as opposed to conventional heating systems, have a few advantages. The first one is the heating uniformity. As you can see in the two houses, the house in which there's radiant floor, we see a heating uniformity as opposed to the forced air house. Now, what this means is that if I stand anywhere in the room, I will be in the exact same temperature, as opposed to the conventional way of heating, which then, depending on where the air comes from, and etc. Now, as well as the uniformity, the energy consumption reduces by 20 to 40%. How does this happen, you ask? Well, the radiant floor heats with beams the floor, which heats the objects directly, as opposed to the conventional way of heating, which heats the air and then the objects. This way we save about 20 to 40% of energy consumption. Now, as well as the scientific knowledge, we know that because the radiant floor heats with beams, there's also a health aspect here. The health aspect tells us that because radiant heating is so clean, as opposed to the conventional way in which dust and infections could be made out in the air. Now, for radiant heat technologies, we have three main ways to do this. The most efficient one, as we see here, is heating ribbons, and it has a covered area of 20 to 30%. Now, this advantage might be the best one we know so far, but it has many disadvantages we think we can improve. The first one is that the energy consumption remains high. The second one is that the heating system coverage of the floor is only up to 30%, and that the heating uniformity is relatively bad as opposed to what we offer. As well, we can see safety issues that may develop flames because it only covers about 30% of the area. We can find places where, if we have, for example here, carpeted floor, would create a concentration of heat in a certain place, which will make flames.
Now that you have a clear idea of the problem we are trying to solve, I'm going to show you which are our goals. Firstly, we are going to improve the thermal comfort, and secondly, we are trying to improve energy efficiency so that also our electricity bill can be less expensive. This image shows clearly what is our idea. Our idea is to make a floor that composed by a typical floor slab covered by an insulation material that is useful to prevent the energy loss and energy consumption. This is covered by a heating mat, that is our heating system. And finally, there is our P.C.M. floor. P.C.M. floor is constituted by micronal P.C.M. that are encapsulated. So, I think that you are asking what are P.C.M. P.C.M. are considered to be a storage material since when the temperature rises, they can absorb heat, and when the temperature drops, they release the heat they previously absorbed. What is important to say is that P.C.M. have a high latent heat of fusion. That means the temperature the P.C.M. have remains constant during the whole phase change. We have a lot of kind of P.C.M. material, and we are sure the paraffin one because their melting point is near to what is our thermal comfort temperature, that is around 18, 22 degrees. And the heating of fusion is around 172 kilojoule per kilogram, and their cost is not too high.
We searched the web and we didn't find any existing P.C.M. floor. However, we found BASF's Micronal P.C.M. panel. And we made sample calculations and we found out that it contains only 50% of P.C.M. inside it. We took two equations of heat transformation, and we found out that the time needed for the fast transformation of 50% of the P.C.M. is 1 hour. In most of the countries in the world, in this time of the day, is the cheapest time of the day, and most time it's cheapest during the night time. And if we could turn on the system with the usage of our P.C.M. floor only during this time of the day, we could reduce our electricity bill. Okay, so like we said before, the existing Micronal panel consists 50% of P.C.M. inside, where our P.C.M. floor consists up to 90% of P.C.M., which means that our P.C.M. contains 6 times more. It can contain inside it, can absorb 6 times more energy than the existing Micronal P.C.M. And so in the time aspect, the time needed for the fast change transformation is 6 hours, which makes a perfect fit to the tariff that we are using. Okay, so apparently now after the 6-hour period, we turn on the system, and now in the next 18 hours we need to make sure that we have a perfect thermal comfort and the temperature will stay the same throughout the whole 18 hours when the system is shut off. Okay, so we made some calculations and we found out that if the house is insulated in a way that every second about 33 watts per square meter will go out of the room, and at the same time the P.C.M. floor will emit 33 watts per square meter. Okay, all of the energy that we gain inside the P.C.M. will go out up to 18 hours, and then the system will start again. And in this cycle, we will keep a perfect thermal comfort throughout the whole day. And in this way, we solved our goal of reducing the electricity bill.
Okay, so basically, we have this new heater that is better than what we showed you before of the disadvantages. So this has a few advantages. The first one is energy saving. That's until 15%. So how does this work? Basically, the difference is between the energy saving that's until 15% is as a result from the coverage of the floor that we have. By covering 90% of the floor, we gain less. We gain less difference between the ground and the floor, and the I'm sorry. Okay, again. Energy saving that's until 15% is between. Can't help instead.
Energy saving till 15%, and the vesting systems that we have today with the vesting installations, still the amount of energy that is lost down is 15%. Okay, but due to the fact that the new heating system that we are promoting covers almost 90% of the area, means that the temperature of the heating system is really low, and the differences between the temperature of the heating system and the ground is really small. So thus we can save the 15% of the energy that is usually lost in conventional heating systems.
Great. Now the floor temperature is close to the room temperature. What this means is that what the floor temperature is close to the room temperature, which means that because it's closer, we don't lose the heat that goes through the air, as opposed to a more distance. What this means is that as long as the system is closer to the floor, we lose less energy out of the space between the floor and the system, which is more energy saved. Now, as well, the covered area is until 90%. What this gives us is much higher heating uniformity. Because it's spread out through the entire room, then we get a higher heating uniformity. Now, as well, this has a long lifetime, which basically means that it doesn't require much maintenance. Now, this maintenance, it's because it's clean energy, it's because it's very simple to install, then it will last for more. And as well, as we've mentioned before, there's a danger of fire. Now, this solves because of the high coverage between all the floor. So for conclusion, we've had our 3 goals. So the first one was to improve thermal comfort. We improve thermal comfort, providing heating uniformity inside the room through the whole day.
And we reach our second goal by reducing the electricity bill by switching on the system only during night time when the electricity bill is less expensive.
The third goal, we fulfilled our third goal. We improve the energy efficiency, raising a new heating system that prevents energy loss by covering more surface. Okay, and how we see the future of P.C.M. usage? We think that if in the future we could find new P.C.Ms that have a high latent heat capacity, which means that they could gain much more energy, and that the panel weight will reduce high surface area of heating elements, and of course P.C.Ms and walls and roof. And we also look in the future, we think that we want to take our P.C.M idea that is meant in this phase of the process only for the winter, and take it one stage up and make the P.C.M floor that we could use the P.C.M floor not only during the winter but also during the summer. And it could be a revolutionary floor.
First of all, I would like to say it was very interesting and well presented. But I've something I'm not sure I understood. You mentioned at the beginning, actually in the title, I guess, infrared. And I saw no use of infrared, specifically infrared radiation, by this method.
I can answer. If we'll go down to the slide over here, we see that the floor itself, what the modifications that we made in the current system is in the P.C.M floor. Now the heating mat is the infrared heating actually. So the P.C.M floor is what we changed. We're changing.
Why infrared?
Because infrared. Okay. First of all, infrared.
Okay. Energy can be transferred by radiation and by conduction. Here, since one layer is on top of the other, most of the energy transfer will probably be by conduction. But actually, it's not even that important if it's conduction or radiation, because you don't care about it. As long as the energy is transferred from the mat to the P.C.M, that's it. The infrared, if there is any, it's not that important. It can be conduction as well.
But I think that infrared is because the conduction and as well the convection are really small here. Okay, because the energy is
one layer, they touch each other, so heat can be conducted easily from the mattress to the floor.
But throughout, because the energy is the same throughout the whole room. There's no convection, so that's why we don't have convection. And the conduction is really small because it's between the molecules of the two layers. But most of the heating, is transferred.
So the infrared radiation, where is it? From the mattress to the P.C.M. or from the P.C.M. to the...
From the P.C.M. to the room. The
But
P.C.M.
then
flow is here.
the temperature difference is very, very small, as you have mentioned. It's only very small. So then the radiation is small.
Because the temperature is small, there's no convection, but there is radiation, because radiation works in a constant. In radiation, there are little differences between the bottom and the roof. Okay.
Maybe I'll ask a question that will help to clarify that. It's still not clear. The temperature of the P.C.M. floor will be what? What is the temperature which you want to raise? You said that, first of all, you said you didn't want...
22 degrees.
Around
You want it to
7
be, sorry, how much?
27.
22 degrees.
Between 20 and 22
Yeah.
degrees.
Comfort, yeah.
Yeah.
So if you bring the floor to, and you want the floor to be at a constant 20 to 22 degrees, and you're saying that this is a better system because you can get the whole floor to be 22 degrees as opposed to just a small percentage if you use the heating ribbons. I'm sorry you didn't
Exactly.
leave the other picture there, and therefore you are going to be, okay, that makes sense. That makes sense. Is there a reason, so two questions. One, where did you get to the number of 90% P.C.M. material as opposed to this material that the BASF is already making at 15%? How are you able to use a paraffin or some other phase change material at such a high percentage?
The whole floor.
You're standing on a floor that's 90% phase change material going between the solid and the liquid.
As we've explained before,
Yeah?
the floor is made out of any other floor. It could be ceramics or concrete or combination of a lot of floors. The P.C.M. itself is in capsules, in micronal capsules.
I understood that.
Make it last, and they don't change the form of the floor.
Where did you get the information, or how are you proposing physically to make a floor that is 90% of these capsules?
Put more capsules in.
And you can understand.
Why can't you make it the whole 100%?
Yeah?
Because then it will be.
Because you can't step on it.
But yeah, 100%.
It's so molded, it's molded.
Oh. Now I'm wondering that you've made a big jump between something that's on the market, which is 15%, to 90%. And I'm wondering, how did you figure out that it's actually physically feasible to add that much P.C.M. into a flooring material, encapsulated as part of a monolithic material?
We made some research, okay, and we know that it can be possible, okay, that 90% because it's inside capsules, because what happens in the capsules stays in the capsules and it doesn't change the form of the floor or anything, okay? So you can put 90% of capsules of P.C.M. inside the floor, and then another 10% that what's the floor made out, all the things that the floor itself is made out of. But if you're asking if it's possible, then we made the research and we can say it's possible.
So why stop at 90?
Because if you do 100, then
It won't be
where's
a
the
floor.
floor itself? You'll extend and you melt, okay?
And if you wanna go over, 100% is impossible. Because if we do have between 11 and 6, we have 7 hours, not 6 hours. But because 100% isn't realistic, then we chose 9.
Okay.
Do you have any clue about the cost of such a capsule, about the entire cost of such a floor, and how much it adds to the cost of a regular floor heating from the floor, from the ground? Do you have any calculation?
Okay. Oh, yeah. Well, we've mentioned in a previous slide that the paraffin cost is about $2.5 to $3.5 dollars per kilogram,
Which isn't that.
which is not very expensive.
It goes to any other floor that you buy.
How much do you need per square meter?
Per square meter, 11 and a half.
Yeah.
Yeah.
11 and a half kilograms.
So it's about maybe $50 per square meter.
Yes.
And how much is heating like floor that heats, that is not is it commercial? Is there a commercial product? Of course, we have commercial products now that are just floor heaters, yeah. And do you have any idea how much? What is the delta between those costs, or how much more expensive
The ones
your
that are
idea?
today?
Yeah, from a commercial product that is available in the market right now.
Like you can also panel.
Yeah.
That we didn't.
No, we did not.
How
But,
much
but
they
you're
sell?
under the impression that the added cost is still worthwhile. That's
Yes.
basically
Yeah.
Also,
what you're saying.
as I mentioned before, the radiant floor, it's a system that doesn't concern maintenance, because you see that the stages, when you saw the stages of the floor, it's not complex and it doesn't require much maintenance, which means that it would probably last for a long time. So it's a worthwhile investment.
Okay.
Okay. Any more questions?
Yes.
Okay.
Your goal is to get uniform flow temperature with using the P.C.M. 18 to 22 centigrades. What happens in the summer?
So
the temperature is high, so it's liquid.
The next stage.
So we've expanded some. We're focusing right now on heating, but it is possible, the technology does exist, of doing exactly the opposite. Instead of making the heat, we're absorbing the heat that's outside, and then when the temperature drops, it can release the heat that is absorbed the whole day. We just chose not to concentrate on that one because it's too long. So. But it's definitely a possibility.
It's possible.
Okay, I have a
Tarek,
question.
last question.
Okay. You want to go for it?
Last question. Zvi?
The last is 2 questions.
No, only
No.
one.
Sure.
Just very short. First of all, maintenance of such a underflow air conditioning is problematic because after a few years you have to replace it, you have to open all the floor, and it's something very difficult and expensive. If you take it into account, and okay, maybe I will leave it at this.
Peter, you asked me that.
Even the paraffin, I don't know for how long will it last. It's not that stable, the chemical product, that you have to replace it, but there are problems might be in the heater as well. And then changing the heater is a problem.
Yeah, we thought about it, we took into account that maybe there's a possibility that we need to change, if something happens to the capsules. And of course, we're not expecting to, take the whole floor apart. And so we thought about making, okay, especially if you make this floor a winter and summer usage, okay, we thought about making a small opening, okay, the floor, and put all the capsules in like a bag, let's say, okay, and you put everything in, and when you need to maintain, to change it, or just take everything out, okay, and it comes with the floor, and everything is built, and, okay, so there's no taking apart, okay.
Thank you very much.
Thanks.
Thank you.